Okay, yeah, cool. So I'll be giving a really whirlwind tour of linguistics. As Graham said, it's a very broad field, but I'll try my best to cover some major parts of it. So to begin, what is linguistics? Linguistics as a field is the scientific study of language and its structure. At a very high level, theoretical linguistics aims to find a very general theory that explains the structure underlying languages, and a framework in which we can describe language as a structure. Now, we can describe individual rules and the types of structures that occur in specific languages. However, one very important aspect of theoretical linguistics is to try and find things that encompass all natural languages. And for this reason, one topic that some linguists are concerned about are things like universals in linguistics, like what concepts are present in all natural languages, how do they come about, how do they express themselves? And insights from theory can also inform more applied research. So we can ask questions like, what are the variations between speakers in a single language? How does this come about from social factors? How does this come about from language change? Also, what are the different types of linguistic structures within and across languages? And how are they processed by the brain? And also, a really interesting question is, how do people acquire a new language at different stages of their life? And how does this change from like infancy when you're acquiring your native language versus your second, your third, at ages like 10, 50, etc. Now, this is a class on NLP, and many of you might be asking, like, why should you care about linguistics in the age of LLMs where everything can be fed into a transformer and then you get a bunch of coherent English texts? I'd like to argue that there are reasons why you should be aware of linguistics. First, at minimum, it allows you to understand your data better and more thoroughly. I think this is especially important when you're characterizing specific failure modes of your model, like you have certain errors. How do you classify them? How can you characterize them? Can you look to previous literature to see how people have explained this from a human perspective? Along that point, it also gives you interesting test cases and frameworks to explore. Linguists like to explore really specific, strange phenomena, and this is a great test bed for a lot of things that your model might fail on. Another thing is, as models become more and more advanced, people are now drawing connections between human capabilities, cognitive and linguistic, with models. I would like to say that if you want to make such claims about how your models or systems are similar to humans, at least being aware of these theories is going to be a necessary starting point, even if you don't agree with them and you just really, really hate Chomsky syntax, for example. And another thing is just like, it's fun. It's cool to learn about, and it's a cool like party conversation. Yeah, so that's why you should care. So as a lecture roadmap, I'm going to give a brief overview of subfields and coverage over various topics. For each topic group, we're going to go over main concepts and research questions that linguists ask, also some current and previous computational approaches, and then some applications to NLP that you might be interested in. And of course, because there's a lot to cover and only about 80, now 75 minutes, this is going to be very dense in certain areas, so apologies in advance, and please feel free to ask questions. So how do we break down linguistics as a field into separate subfields? One way we can do this is by looking at the structures that we are studying. So here I have a list of different subfields increasing in abstraction. First, we have phonetics, which is the study of individual speech sounds, and for sign languages, gestures. One level above this is phonology. How do we actually organize these sounds and gestures in the mind? What makes coherent categories and languages? Then we go up to the word level. How are words formed? Then from words to phrases and sentences. And then combining a bunch of different parts together, how do we extract meaning from these different forms? And then how does meaning change and adapt in language use and context? Now I presented these categories in very discrete boxes, but it's really important to remember there's a lot of like bleeding between categories. Like between morphology and syntax, there's a whole field of study called morphosyntax. Same thing with the syntax semantics interface. We can argue for days about what the actual difference between semantics and pragmatics is. I'm going to ignore that for now, along with a lot of other things. And we can even span the whole gradient from phonetics to pragmatics when we talk about like prosody, inflection, and stress. So there's lots of different interactions that can occur here. While I am presenting them in very discrete forms, do keep that in mind. So I have described kind of like the separate subfields based on structures, but we can also apply these to other areas like neurolinguistics. How does language work in the brain. Psycholinguistics, like what is the psychological reality of structures? How do we process them? Sociolinguistics deals with like social context. How do speakers vary based on like their social setting? Linguistic typology, what are the different variations between languages? And historical linguistics, how has language changed over time? And as much as I would love to cover all these things, I'm going to mainly focus on the things on the left. And across all of these different subfields, we can use computational methods to explore questions within and then also across subfields. So in this lecture, I'm going to break down things into three main parts. First, we'll start with sound and gesture, then we'll move on to subwords and constituents, and then we'll move on to meaning and intent, roughly broken up in these parts. But like I said, everything's a continuum, so things will be referred to, or like we might advance a little bit in certain sections. So with that being said, let's start with sound and gesture. Okay, so at the very basic level at phonetics, we can study speech sounds and gestures, specifically how we produce them, like what are the functions in our body that we do to actually create sounds, how we perceive them, like how does the actual physical property of the waveform, for example, turn into our perceptions of like pitch and volume, and then how we can analyze them. So we can look at physical properties and mathematical properties of these waveforms, break them down into like their spectral components, etc. So one very important distinction that we need to make when we study things like phonetics is that there is a discrete separation between how things actually sound and how they are spelled. In phonetics, the actual like atomic unit that we study are things called phones, and these are individual speech sounds. So it'd be like P in the sound for the English word hat. We need to keep in mind, as like we work with text a lot, is that one thing to keep in mind is that text is not a one-to-one mapping between characters and these sounds. And this is very obvious in certain scripts. So for those of you that know how to read Chinese, for example, Chinese is very logographic. Even though there are some indications in the character of like how you might pronounce it, it's very sparse in certain for certain characters, and there's little indication of how you would actually say certain words. Other scripts have very consistent spellings for sounds that are one-to-one, so we can determine the exact pronunciation of a word based on its characters. So this would be things like Japanese kana, which are that show each syllable. Spanish is also very easy to pronounce once you know the rules, and Hindi also falls in this category as well. Some other scripts, oh, yes.
So does that mean that sound is more granular than text?
Sound is more, well, it depends on the script. Like sometimes you can, like there is a script called the IPA, which is exactly one-to-one between the sound that you produce and how it's spelled. But for the most part, the way that you would represent the exact sound is always going to be more granular than how it's spelled in orthography. Yeah.
Thank you.
Mm-hmm. And then finally, especially for those of you who acquired English as a second language, or even if you are a native English speaker, you know that certain words are really weird to spell and really weird to pronounce. For the longest time when I was a kid, up until I was maybe 7 or 8, I thought chaos was pronounced chows. Even though there are very general rules about how you would say something in English, there are exceptions that have to be made and have to be learned. And this happens as well in French. So between scripts like English and French, which are harder to get those irregular forms from, we call those deep orthographies. And then the ones that are very one-to-one, like Japanese kana, we call them shallow orthographies. So because there are so many different ways to represent sounds across languages and scripts, we as linguists use something called the International Phonetic Alphabet. And in brackets here are how you would actually write IPA using IPA. So this is like the updated chart from, I believe, 2022. I think it says, but my video is blocking it from what year it's from. But it basically categorizes a bunch of sounds and then shows you the exact character to write to represent that sound. One computational tool that you can use to convert from some orthography to IPA text is Epitran, which was actually developed by David Mortensen here in LTI. So another aspect of phonetics that I touched upon in the intro slide is how we actually produce sounds with the body. So this is what articulatory phonetics studies. Basically, with spoken language, various organs in your mouth, nose, and throat can modify airflow from your lungs into your lungs, and that's how we produce different sounds. And based on how these different modifications occur, we can get different types. So very coarsely, we can categorize sounds into vowels, which are produced without much restriction, consonants, which are produced with some partial or full restriction, and then finally, semivowels, which are kind of between a consonant and a vowel. These are sounds like y and w. And then we can break down some of these categories even more. So for consonants, we can categorize them based on their place and manner of articulation, like the sound I create by putting my lips together, and then like nasalizing. We can get into that another time. But basically, we can categorize based on the placement and manner, as well as whether they're voiced or voiceless. So the difference between like t and d is that there is vibration in my vocal cords, and that's the distinction between voiced and voiceless. Vowels can be categorized in a different way based on the position of your tongue, how open your mouth is, and the roundedness of your lips. I really like the IPA chart for vowels because it's actually very intuitive. Imagine someone splits you right down the middle like this and then takes a cross section, and that's kind of how you can map the vowels to the vowel chart. Vowels are typically voiced, but voiceless vowels do actually exist. So we've covered the basics of phonetics. Now we can move on to phonology, which is the study of the categorization of speech sounds or equivalent gestures in sign languages. Now, in contrast to phonetics, which deals with the physical properties of sounds, regardless of their context, regardless of what language you're actually speaking them in, phonology now deals with abstract rules or constraints that govern interactions of sounds within a language and also like your mental reality of how you perceive sounds. So some questions that phonologists might ask are like, what sounds are meaningfully distinct in a language? How are sounds organized into syllables? And then what rules govern allowable sequences of sounds? So, like I said before, phones, which are the like basic unit of sounds for phonetics, they're individual speech sounds. But in phonology, what we're actually concerned with are things called phonemes. And these are perceptually distinct units of sound in a language. Phonemes are sounds that can distinguish one word from another. So in English, pit is a different word from lit. So we can say that p and l are different phonemes. If we gather a set of all of the sounds that can create these distinctions of meanings in a language, we have the phoneme inventory of that language. So a really fun fact here connecting phonetics and phonology and psycholinguistics is that over time, with the languages that you speak regularly, we are conditioned to limit our mental distinction of sounds to, as well as production sometimes, to those that are distinct in our native languages. Whereas babies can perceptually easily distinguish between all the different phones. And they did the study where they had like babies like either changing attention or like sucking on a pacifier. And if their like rate of sucking increased, it means they've like sensed a new thing in their environment. So they tested with a bunch of different phones and they saw that like the babies could distinguish between them. But especially if you're like not a native speaker of a tonal language and you try and distinguish between tones in Chinese or something, it's really hard to tell. And your brain has like learned to abstract away from all of those things that are not distinct in your language. But we can still relearn these things. It's just a fun language acquisition fact I threw in there. Yeah, so let's run through an example. Oh, yes.
To try and summarize that, is it right to assume that phonemes are language specific?
Mm-hmm. Okay. So how can we like formalize phonemes and how they operate with specific sounds like phones? Let's run through an example in English. So p with no puff of air and a p with a puff of air are two distinct phones that are actually used in English speech. So if you hold like your hand or a piece of paper up to your mouth and you say the word spat, you probably won't feel much air come out of your mouth. But if you say the word pat, there's like a bit of a puff. However, if we were to like manipulate a sound and change the puff with no puff of air, which is unaspirated, for the puff of air, puh, and vice versa, we wouldn't change the meaning of the word. Like you can say spat and spat. one with a puff and one without, and they mean the same thing to me. So what does this tell us? This shows that the P with no puff of air and the P with the puff of air are instances of the same phoneme. In other words, they are allophones in English. Allophones are phonemes that map to the same, or phones that map to the same phoneme. In other languages, though, we can distinguish between these two sounds. Like in Thai, the P with no puff of air and the P with the puff of air would actually change the meaning of a word. So their phoneme inventory would include both Ps. And how these phonemes actually occur at like what actual sound you make is determined by the context that it is in. So whether this phoneme P is produced as a P without a puff or a P with a puff can be determined by the sounds that surround it, which we call its environment. So an observation that we can make is generally for standard American English, aspiration only occurs when this P phoneme is at the beginning of a stressed syllable. We can also see, though, that this happens with other sounds like t and k. It turns out that p, t, and k form a very salient group of sounds called unvoiced stops. So we can write a phonological rule. These unvoiced stops will be aspirated at the beginning of a stressed syllable, otherwise they will be unaspirated. Okay, so kind of ran through the basics of phonetics and phonology. What are some applications in NLP? A really cool one, which also ties into historical linguistics, is automatic proto-language reconstruction. Over time, because of like just the physical properties of your mouth and social factors, you will have phonological changes of how you produce words and sounds over generations. And this can give us clues as to how languages have evolved over time and how they're related. So there have been some work to uncover these types of patterns computationally. There's also really cool work on cognitive models of human speech production. So this recent work from Berkeley was training an unsupervised speech synthesis model, which instead of producing from raw waveforms, instead trained their model to produce human-like articulatory gestures based on like electrical signals that people have measured from people's mouths. It can also serve as a form of linguistic evaluation of things like phone embeddings. If you have embeddings of phones or the individual sounds, do they actually also encode phonological relations? And then finally, we can also incorporate phonetic information into word embeddings. So this can be applied to tasks like cognate and loanword detection, multilingual named entity recognition, lang ID, etc. Okay, so now popping one level up in abstraction, we can move on to subwords and constituents. So morphology is the study of word formation and structure. And if you've ever like armchair philosophized or thought a little bit too hard about what you were saying, you might be like, what is a word? Do words exist? And this is actually a very valid question. Lots of linguists have thought about this. Lots of linguists continue to debate about it. If you ask someone who's really opinionated, they will go for a very, very long time talking about whether or not they believe a word exists. But for now, we're going to forego that debate and just go with our intuitions for what a word is. Words are formed from linguistic units called morphemes. And like how a phone was like the smallest unit we would study in phonology, a morpheme is the smallest unit we study in morphology. These are the smallest meaningful linguistic units. So I can break the word morphology down into two morphemes, morph, which means form and shape, and ology, the study of. So one thing I'd like to note is that in this lecture, most of my examples are going to be English because I know all of us speak English, but English morphology is super duper boring. So you can check out some really cool, fun polysynthetic languages or ones that have a lot of like morphological processes that go on, including many indigenous American languages for more fun examples. Yeah. So for the most part, we can break down morphemes into two categories based on the following properties. First, we can ask, can a morpheme occur by itself? If a morpheme can occur by itself, then it's basically a word and we call it a free morpheme. But if it can't, then it's bound. So like in dogs, we have a free morpheme dog and a bound morpheme for the plural s because that just can't occur on its own. But we can also form words that are composed of all bound morphemes, like multilingual. Another thing we can ask is whether or not it comprises the main meaning of the word. If it does, it's the root. If it's not, it's an affix. So like in dogs, the affix on its own just indicates that it's a plural, but not really of what. So the main meaning is with dog. Another like weird thing is cranberry morphemes. So if we try and split cran and berry, cran doesn't really mean anything. So it's a bound morpheme without like a real meaning, which kind of contradicts what I said about a morpheme having a meaning. But this type of thing comes about from historical change. So cran actually did have a meaning back in the day, but it no longer does now. So one type of morphological process is inflection, which can create a new form of the same word. Basically, the main concept and meaning of the word will remain the same, but we're like flipping a switch for the grammatical feature of, or some grammatical feature in the word. So like in the dog's example, appending an S makes it plural. For person, I can say I run to he runs, hence I climb, I climbed, etc. In contrast, we have processes of word formation. So one of these is first derivation. It's a process that creates a semantically related new word by operating on a base form, often through things like affixation. So now the main concept and meaning of the word is going to change, and oftentimes part of speech will change too. So you have to teach, a verb, to teacher, someone who teaches, intends, to intensify, easy, easily. But we can also have derivations that don't change part of speech like unlucky and lucky, where they now kind of have opposite meanings. Another word formation strategy is compounding, and this is a process that creates semantically new words by combining two already separate words, like blackbird, ice cream, skyscraper. German is infamous for this, so this like super long example here means cattle marking and beef labeling supervision duties delegation law. Yeah, that's fun. So all of the things I've shown you, especially with the English examples, are pretty simple. We just like root, attach things sequentially to the root, boom, word. But not all morphological processes are this straightforward. So in English, we do have something called apophony. So this is like a vowel change, tooth to teeth, plural, goose to geese. Unfortunately, not mice to meese, but that would be fun. Infixation, also fun. There's a fun example in English. You can read it. I won't read it out loud. Transfixation is when you have like some root, but it's actually split when you put the new affix in there. So this happens with Arabic and Hebrew roots. Reduplication, in Indonesian, this happens pretty often. We have the verb berjalan, to walk. And then we reduplicate the root to become to stroll, berjalan-jalan. And then there's also a lot of other processes that I haven't listed here. Computationally, we have useful tools for this called morphological analyzers, which take as input a word form and then output all possible morphological parses of that word. So traditionally, this is done with FSTs. And it's a two-step creation process. It's actually pretty arduous. First, you gotta map your lemma and a morphosyntactic description of the morphemes to an intermediate form that represents like the basic morpheme representation of that label. So for example, you have like bus, the lemma, PL for plural for that description, and then that maps to bus, and then S as the canonical morpheme representation of the plural. And then you have another one that maps from intermediate form to surface form according to some like orthographic rules, phonological rules, etc. So now you go from bus with the plural S, but it's actually written out as buses. You put these together, and then you can have as input your bus PL and then get as output buses, but you can also invert it. So now you can use it as an analyzer. And some tools to construct these type of FSTs are FOMA, REST FST, and OpenFST. But obviously, we don't really use a ton of FSTs anymore in modern NLP. So now, more recently, there's neural models that like sequence-to-sequence models that just do this with the word as a raw input and the analysis as the output. But we can still combine approaches. So you can combine an FST with your predetermined lexicon with a neural guesser that can handle unseen word forms. We can also use FSTs to generate additional training data that can be used as input to your neural model. Even though like I wouldn't guarantee that not all of us use FSTs, but like more generally, the broader NLP community doesn't really deal with them anymore. These tools are really, really useful for low resource languages and for annotation of those low resource languages, like in this example for UPick. Okay, so we've gone, yeah.
Sorry, one quick follow-up is, like Lindia pointed out, that English morphology is really boring. Chinese morphology is even more boring. So if you speak Chinese, you also don't deal with a lot of morphology, but most other languages in the world have more complex morphology than English. And especially the ones that, if you could go back a few slides, the ones that have like infixation, for example, where you're changing the characters in like the middle of a sentence, actually they break some of the underlying assumptions that we have in our like neural models nowadays. Like, for example, we're using BPE or something or sentence piece or something to split words. That works really well in English, where we mostly have concatenative morphology, where you just stick two things together, but it doesn't work well when you're inserting characters in the middle of the words. So like it's kind of interesting to know these differences from the point of view of modeling, if you're modeling one of these languages, because that actually becomes a really big problem if you start doing like Arabic or something like that, and you just use our existing models. So that's just another point about why knowing this is important if you're.
Yeah, and if you want to know more, David teaches a really cool class on subwords, where you deal with like tokenization stuff and morphological processes. Right. So we've covered words. Now let's put them together. Syntax is the study of how words form phrases and sentences. So like the question that a syntactician might ask is like, what are the principles governing phrase and sentence structure within a language, and then also across languages? So aspects of syntax include word order, like does your subject come before your verb and then followed by your object or some other combination? Agreement, like subject-verb agreement, and then also what is the nature of the hierarchical structure of the syntax. And then I have a fun example from Twitter about how some English sentences look like 9 consecutive nouns, which I thought was funny. So words, like there's a lot of categorization in this lecture, and words are no exception. We can categorize them based on their morphological, syntactic, and semantic properties. And we refer to these categories as parts of speech, like nouns, verbs, and adjectives. I'm sure you all are very familiar. However, one thing to note is that this categorization is like not a very strict one at all, and it should not be taken for granted. As you study like more and more complex or languages that are just completely different from English, you'll realize that some of these boundaries between like nouns and adjectives or verbs and some nouns is actually really, really blurry. So even though like this is very like, a noun is a person, place, or thing, and a verb is like an action, it actually is a bit more complicated when you factor like morphosyntax into it. So keep that in mind. A very broad distinction we can make over all sorts of words is whether it's an open class word or a closed class word. So open classes of words are classes where we can add new items easily over time and with relative ease. So if any of you guys are like online, we have a new word like Riz derived from charisma, and it can be a noun like, oh, he has so much Riz, or it can be a verb like, oh, he rizzed her up, fun. And then closed class words, you have a much smaller number of words, and it's a lot harder to add new items over time. One exception to this, though, recently is with pronouns. Like people are a bit more productive in how they use pronouns, a bit more flexible, at least in English and in the US. And even based on how words act in context, we can often infer the part of speech, even though we've never seen it before. Let me move this. As in this example, which you might have seen if you've ever taken a linguistics class, it's like everyone's favorite part of speech example. It's by this poem called Jabberwocky by Lewis Carroll, where he has a bunch of nonce words. But we can kind of tell, even though we've never seen the word before, what its function in the sentence is. Like all mimsy were the borogoves, like borogoves has to be a noun here, it has to be something, and they were being mimsy, whatever that means. So yeah, here's a list of canonical parts of speech. Sometimes Based on a linguist's desired annotations, we can get more narrow than this, but this is like pretty standard. And then like a sentence annotated for each part of speech, like they is a pronoun, had is an auxiliary verb, argued is a verb, etc., etc. I won't spend too much time on this because I think it's a bit too nitty-gritty in the details. So a big part of syntax is phrases. Like what are the types of phrases we have? How are they formed? Here are three very, very basic ones. So a noun phrase, obviously, as the name suggests, contains a noun, but it can also include a determiner to tell you like what set of nouns are you referring to? And then also things that modify the noun, like adjectives. So here's a noun phrase, the old man. Old man is also a noun phrase. Man is also a noun phrase. A prepositional phrase has a preposition followed by a noun phrase. Some preposition phrases. We can extend the rules to be more complicated, but here's a very simple example, like to school. And then verb phrases contain a verb and then any other noun phrase or prepositional phrase that the verb requires or has a slot for. My video keeps getting in the way of my slides. So as well as any other adverbial modifiers, like sold a car to me. Very simple. So constituents consist of at least one contiguous word and behaves as a single unit. This is like one theoretical unit that is very important in generative syntax. So let's look at this example. Beyonce released a new country album. A new country album, as we saw in the previous slide, is a noun phrase. A crucial observation to make is that we can continually replace a new country album with smaller and smaller units all the way down to the word level. Like Beyonce released a new language model. Even shorter, Beyonce released a balloon, or Beyonce released lanternflies. So yeah, we can see that all of these things like act as a single unit and they all act in very similar ways. So as a follow-up to that, some people have developed a theory of language in the context of context-free grammars. In linguistics specifically, these are called phrase structure grammars, and it's introduced by Noam Chomsky, who I think actually gets a lot of flack from NLP, but people need to realize he was actually really, really important for linguistics. Like he has some pretty good ideas, even if not all of them are correct. So Noam Chomsky defined a phrase structure grammar as having a finite vocabulary, a finite set of strings that are part of this vocabulary, and then a finite set of rules that operate on the vocabulary to produce strings. Or more strings. And we can use these rules over and over and over again recursively to create infinitely long strings that are still parsable. So here are some very simple phrase structure rules for English. A sentence is defined to be a noun phrase followed by a verb phrase. A noun phrase can be constructed by having an optional determiner and another noun phrase, and then we can take that noun phrase and decompose it into another optional adjective phrase, a noun, a prepositional phrase, so on and so forth. Now, using such a set of rules in our phrase structure grammar, we can generate lots and lots of English sentences, including those that are syntactically proper, even if they are semantically nonsensical. So like playing Mad Libs with these phrase structure rules. A very famous example from Chomsky is colorless green ideas sleep furiously. Doesn't really mean anything, but as a native English speaker, you're like, you know, it sounds right even if I don't know what it means, which is a really cool observation. Like speakers have an intuition for when things sound syntactically correct, even if they have no meaning. But if you're wondering, you know, all these like sets of rules, it seems way too simple, like people mess things up all the time, or there are lots of other constructions that can't be explained very easily by these rules. Well, yeah, you're right. Some phenomena are very difficult to model in this fashion, but you know, this is like a very, very old grammar back from the 50s. There are lots of new frameworks in theoretical linguistics, such as minimalism, which is a Chomskyan tradition. There's other formalisms like HPSG, cognitive linguistics approaches like construction grammars, etc. So it's a lot more wide and varied than just what you see canonically in intro ling or linguistics lectures and NLP classes like this one. However, it's still a very conceptually powerful and remains influential. So a very important aspect of this line of work and a lot of subsequent and competing theories is the idea of hierarchical structure in syntax. So using these phrase structure rules, we can break down the sentence into a tree where the sentence node S is the root and the words are the terminal nodes and their part of speech is the one right above it. We can also have syntactic trees that reflect ambiguity. So here we have two trees for the same surface form sentence. I saw a girl with a telescope, but they mean slightly different things depending on how you interpret with a telescope. Are you seeing the girl, do you have a telescope in your hand, and are you seeing the girl with it? Or are you seeing a girl who has a telescope? You can represent these two interpretations differently in syntax. So what I just described earlier were like parse phrase structure grammars that are based on constituency relations. But there are other types of ways we can parse sentences, such as dependency parsers. Dependency trees are based on dependency relations, sometimes referred to as grammatical relations, and these are binary asymmetrical relations that connect words and phrases. So in the abstract, a relation A goes to B, A is the head, and B is the dependent of A. You can define a relation in many different ways: syntactic, semantic, morphological, prosodic, but most frameworks will focus on syntactic relations with the main verb serving as the root of the tree. So we can have clausal relations, like whether the dependent is a nominal subject, direct object, indirect object. We can also have modification relations, like is something modifying a noun, or like is a noun modifying another thing, is an adjective modifying another thing, etc. So here is an example of a dependency parsed from universal dependencies. Here, like in the top example in English, chaste is the head of the tree, and you can like follow the arrows to see like what are its dependents. So part of speech tagging and syntactic parsing used to be a big deal in NLP, but there's a reason why you don't have a lecture on that anymore. Especially because when we're dealing with high resource languages like English, it's not a super big deal. But it's still a very valuable resource for people studying lower resource languages. And having lots of linguistically annotated corpora over a wide variety of languages can also enable us to do like broad range linguistic studies. So here are just some examples of corpora. In English, like some major ones are the Brown corpus and COCA for part of speech tagging. For constituency parses, there's the Pren tree bank. For dependency parses, we also have Google Syntactic Ngrams, and then universal dependencies. This one is actually quite interesting. There's over 140 languages with a bunch of dependency parses. And it's still a continual effort to develop more and more descriptive annotations. So very recently, this paper came out to like have a layer of constructions on top of existing universal dependencies parses. Okay, yes.
Why do we assume there are universal dependencies, like consistent across all languages?
This is a question that like typologists are like very concerned with. I think it's for construction grammars and people who deal with like this, how are certain semantic concepts, like how do they emerge in the structure of a language? I think there's some assumption to be made on like very basic forms of meaning that all humans try to communicate. And then from there, how that's actually expressed in the grammar might differ, but there are like, because there are those base meanings, there are going to be comparisons that can be made across languages. But that is like a very hot topic in linguistics. Yeah.
Yeah, and I think as another comment, there's universal part of speech tags, kind of like the ones that Lindia showed in universal dependencies. These are like aggressively simplified to only have the things that occur in most languages. And so then there's other languages that have other things basically that go beyond this. But by aggressively simplifying, you can at least like make it very easy to do comparative studies across a lot of different languages.
Yeah, a lot of times they'll have like what Graham said, these very coarse grained tags, and then as another column in the annotation have language specific tags to be a bit more descriptive and like show when things might not necessarily align with the broader label. Okay, I think now we're going to enter things that are a bit more computationally like NLP relevant with meaning and intent. So semantics is the study of linguistic meaning, and we can study this at various levels. As we saw, we could see what a morpheme means. We can ask what a word means, what a sentence means. And this often interacts with morphology and syntax, as we saw, like appending certain morphemes causes your word to mean something else now. A really active area in linguistics as well is the syntax-semantics interface. Like, what is the relationship between syntactic form and meaning? How do different meanings of words change how they act syntactically in a larger structure? Now, semantics is obviously a very, very broad field, and we can very easily veer into philosophy of language, semiotics, what is meaning anyways? We're going to stick to computationally relevant topics here, but even then, like, I still don't have time to cover certain topics like propositional and first order logic. So if these things sound interesting to you, I encourage you to like look them up. They're quite fun. So let's start with lexical semantics, which I think is a very intuitive notion for people. A sense of a word is a distinct meaning of a word. And as we all know, words can have multiple semantically related senses, and we refer to this as word polysemy. So I can say like, they run experiments, they run races, candidates run for office. Can I run this idea by you? We're all using run. We kind of have an intuition of how they're similar, but also a bit different, et cetera, et cetera. A related concept, but not exactly the same, is homonyms. And this actually is kind of a blurry distinction. So a canonical homonym in English is something like bank, like river bank, versus I went to the bank and got some money. But if we actually look at the historical traces of like the meaning of bank in these two settings, we'd actually see that they're actually polysemous. But over time, as our uses of these words have changed in context, we've seen these meanings drift further and further apart. So now they're homonyms. But in the context of NLP, whether it's a polysemous word or a homonym, they kind of give us the same issue, which is we have two surface forms, which in text appear exactly the same, but they have different senses. So not only can we talk about like how a word has many different senses, but we can compare a word and its sense to other words and their senses. And we call these like lexical relations. So in a thesaurus, you'll have lots of synonyms and antonyms, where synonyms are things that are about the same meaning. Antonyms are things that are opposite, like hot, cold, very simple. There's also other relations like super subordinate. Like if I say vehicle, that encompasses all cars, and all cars and all SUVs are encompassed by cars. And you can go all the way down into like a very, very specific car, like my dad's old Honda Odyssey. It's like a very specific instance that is covered by the large umbrella of vehicles. We can also talk about part-whole relations, like toe is a part of a foot, and a foot is a part of a leg, and a leg is a part of a body, et cetera, et cetera. So one really large project back in 2005 was to take a bunch of English words and kind of categorize them based on their relations to other words. This is WordNet, which is a very large database of English words, where they basically took all the content words like nouns, verbs, adjectives, and adverbs, and they grouped them into sets of synonyms, which they call synsets. And then for each grouping, they would link one grouping to another through these conceptual, semantic, and lexical relations. So a very common relation that would link one group of synonyms to another group of synonyms is like the super subordinate relations, like I talked about. So all of the things that are grouped together with vehicle are above things that are grouped together with car, and so on and so forth. They also distinguish between types, which are common nouns like car or president, and instances, which are proper nouns. So president is a type. Obama, Trump, Biden are instances of that type. And instances will always occur as the terminal node in these WordNet hierarchies. Since then, they've created lots of WordNets in other languages. And an interesting consequence of WordNet was ImageNet, which based its hierarchy of images according to the groupings of nouns in WordNet. Though one caveat I have for this is because WordNet was constructed with English and then with very specific annotators of that spoke a certain type of English, your hierarchies are not going to map very well conceptually across cultures and languages. So that's one consideration to be made about like grouping words in this way. One really important theory that comes from semantics is the distributional hypothesis by Zelig Harris, which, fun fact, was actually Chomsky's PhD advisor, but have birthed two completely different schools of thought in linguistics that are often at odds. And this hypothesis was that linguistic items that have similar distributions in use will end up having similar meanings. A very famous quotation that kind of rephrases this is, "You shall know a word by the company it keeps." And this idea is the foundation for lots of statistical approaches to semantics, both lexical and otherwise. So I think you guys have already talked about this, but we can, given a large corpus, form vector representations of words based on their relationships and where they appear in context to other words. With these vector representations, we can show sense relations with cosine similarity. So if they're synonyms, they'll probably end up in very close in space. So if we take their cosine similarity, it'll be very close. And then if we do vector arithmetic operations, we can see like analogical relationships. So one example was king to queen is like man to woman, where the resulting differences are very similar. We have in modern NLP, I guess, two main types of word embeddings: dense static embeddings like word to vec and glove, and then contextual embeddings like Elmo and Bert. The drawback from using things like static embeddings is that they won't capture polysemy and homonyms. So it would just be one representation for all instances of that written word, whereas with contextual embeddings, we can make that distinction. Another very, very important concept in semantics, and I guess in linguistics in general, is this idea of compositionality. So from all the other slides that I've shown, especially with morphology and syntax, it seems that a lot of natural language is basically by like taking smaller units, putting them together, and then we can kind of see how as a whole, we have a certain structure that conveys a certain meaning that is derived from the meaning of individual parts. So this was very clear in things like morphology and a bit less clear, but still there in syntax. So in sentences, for example, we can combine the meaning of individual lexical items and phrases, and then maybe even other constructions. A very important thing as well is that we can create novel sentences and structures systematically through compositionality. And similarly, we can determine the meaning of novel sentences and structures. And this is still an open question as to like whether modern models can do this and to what extent, if they do. There are a couple of compositionality benchmarks. One of them is COGS, which uses like semantic representations. There's also another paper, like kind of a survey paper on like compositionality in NLP and like how people have evaluated these types of things. And I guess they pressed for more evaluations that occur on natural data as opposed to like artificial data. But there are also exceptions to compositionality, such as idioms and figurative language. So this is a really funny viral tweet on the Chinese McDonald's menu translations. So like this one says, "Unsuspecting tyrant double-decker beef fort." So like if you've ever looked at a Chinese menu and been like, wow, that is a really strange dish name, it's because like they're very figurative dish names and they don't translate very well when you do like a word by word translation. So obviously this is a challenge for applications like machine translation, but also like more culturally sensitive language technologies as well. So kind of switching gears, one aspect of an expression's meaning, although it doesn't encompass everything, is the truth conditions or the conditions under which the expression would be considered to be true. So for example, if I say it rained in Pittsburgh yesterday, this would be true only if it actually rained here yesterday, and because it did, the sentence is true. Pretty straightforward. But we can also have relationships between expressions that consider truth conditions. So the definition of an entailment is that if A entails B, then B must be true if A is true. In other words, we can say that B is a truth condition of A. So if I say something like, Emmy is my adorable little orange cat, which is 100% true, this entails that Emmy is a cat, and she is indeed a cat. So entailment is something that's an object of study in a task called natural language inference. This is an NLP task where, given some premise, sentence, or text, determine if a hypothesis is entailed, or contradicted, or neutral, given that premise. So there are lots of data sets that deal with this, like SNLI, multi-NLI, SciTail, etc. Here are just some examples. I don't know if you guys can read, but it's like one of the text premises is a man inspects the uniform of a figure in some East Asian country. These are all annotations of images, by the way, if they're a bit strange. And then the hypothesis given that text is the man is sleeping. Well, since he cannot be sleeping if he's inspecting uniforms, this is a contradiction given the premise. So NLI isn't really a super popular task these days, but it's still pretty useful. So we can use entailment models for things like factuality checking of generated text, or seeing if two sources agree in like something like fake news detection. So especially for like maybe retrieval augmented systems, we can check if the generated answer is entailed by some retrieved source text. Okay, so I think I'm actually going a lot faster than I thought I would, but pragmatics is an area where you can ask a lot of questions. So, and there's also a lot of ripe things that we can look at in NLP. So this, as opposed to semantics, pragmatics deals more with language use and context. So how is language used in social interactions? How does context, linguistic or otherwise, actually influence how we say things? What do we actually intend to mean when we say something, and how does this influence the interpretation by the listener? A very prominent theory in pragmatics is something called the speech act theory, which says that the meaning of like something that you say is not just comprised of the statement itself, but also of the intended effect that you meant to have on the listener. So a very simple example of this is asking like, can you pass me the salt? Like, I'm not asking if you can literally physically pass me the salt. I'm requesting you to pass me the salt. Another funny one in English is like the do you mind type of construction, where like if I say, do you mind if I sit next to you? And you say yes, like if you're answering literally, you're saying that you mind, so you would rather me not sit there. But most people, when they just say yes in isolation, they actually mean go ahead. But if they say no, it's a bit weird and they have to follow up with I don't mind. So this is a difference between like what you literally say versus what you actually mean. And of course, like given this like difference between what's literally written and what's actually meant to be said, you can see where a lot of problems and like ripe research areas might be in NLP. So one important thing to remember in pragmatics is the idea of presuppositions. So in discourse, we kind of have like an agreement on what we know and like what we're talking about at the moment. And we have implicit assumptions about the world that we act on. So I already told you guys and showed you a photo of my adorable cat. So if I say something like, everyone thinks my cat is cute, which is true, this presupposes that I have a cat. It would be super strange for me to say something like this if I didn't have a cat. And also if no one knew about my cat. So presuppositions can be triggered by certain lexical items or constructions. So some examples of this are definite descriptions, like the current king of France. Current is missing here, but if I said the current king of France, the kind of presupposes that I'm referring to one thing and that one thing actually exists. But France does not have a king at the moment, so saying the current king of France kind of has a false presupposition. Another thing is factives, which kind of, when you use certain verbs, you're kind of relaying the subsequent information as things that are necessarily facts. So if I say something like, which is also 100% true, I regret drinking the Vietnamese cold brew from Red Hawk. I couldn't sleep. This presupposes that I did in fact drink cold brew from Red Hawk, and that did happen. But if I didn't drink cold brew from Red Hawk, then this would also have a false presupposition. This also happens in questions like, which linguist invented the light bulb, presupposes that some linguist invented the light bulb. But there is no linguist that invented the light bulb, and this is actually the title of a paper by Nadran Kim, which looked at a bunch of question answering data sets, and they found that certain questions are just unanswerable. So it makes no sense to evaluate NLP systems on these questions because they have false presuppositions. There's no way you can answer it factually. And there's a lot of other different types of triggers, but these are just a few. Another concept is implicature. So in semantics, we talked about entailment, like something that must necessarily be true if I had done something before that. But implicatures are slightly different. These are things that are suggested, but they're not necessarily literally expressed. So I can say something like, if it's lightly raining outside, cloudy and kind of gross, like, oh, today's weather is the worst. I don't actually mean that it's literally the worst. Like it could be a lot more worse, but I'm basically implying that it's bad and I don't like it. I have a distaste for it. But that's not actually what's present in the thing I said. Yes.
Question about this.
Mhm.
Question with the presupposition.
Mm-hmm.
Why exactly is this like bad to have in an evaluation data set? Because wouldn't this be a good indication of whether your model can identify the presuppositions and then identify whether that presupposition is true?
Yeah, I think the issue was that was not, they were trying to, like, with question answer evaluation data sets, that wasn't the thing that they were looking for. They were looking for like some string. So I think investigating whether question answering models can detect such false presuppositions is like a good thing. But if you don't actually identify that as a problem in your data to begin with, then it kind of messes with what, like if you're just doing like a raw question answering evaluation, it will mess with your end results. So it was more of a mismatch between issues in the data and what people were looking for. Yeah. But that's a good question. Right. So another example, which is a bit more salient, like let's say I ask you in conversation, are you going to see the eclipse on Monday? And you respond, I have work. What is being implied by I have work? Like, no, right? Like, you know, I have to go to work, therefore, like, you know, I can't go out and skip whatever to see the eclipse. But you could also say, I have work, but I'm going to go anyways. So unlike entailments, which are necessarily true if the premise is true, implicatures are defeasible. If we add additional context, be it linguistic, like in more words, or like in just a social context, we can change the thing that you're actually going to imply. So one example is like, let's say you're a real estate agent and you're showing people houses. You can say, oh, this house has 2 bedrooms. And what you're actually saying is like, this house has exactly 2 bedrooms. But let's say you're hosting some guests at your house and you have exactly 5 bedrooms, but they only need 2 bedrooms to stay at your house. They ask you like, oh, do you have space for us? How many bedrooms do you have? And you could be like, oh, well, I have 2 bedrooms. Like, it doesn't have to be true that you have exactly 2, but you have 2 available bedrooms for them. So this is an example of where like extra linguistic context can change what you're implying in your statement. Yeah.
Yeah, and I also want to point out that this is a super good example of how different varieties of linguistics interact with each other, because Lindia changed the way she said I have 2 bedrooms in those 2 cases, right? And like the tone of your voice and stuff like that, that's called prosody. And like you can change what you mean, you can change semantics through prosody. And like I just thought this was too good of an example because like you can't really say, yeah, you'll change the way you say something if you want to like make it clear that the nuance is different.
Yeah, we have more examples of this later.
Okay, sorry.
No, but like it's a different type of example, but like it's good have that pointed out. Yeah. So this kind of thing relates to the overall question of how do people actually conduct conversations and how do they achieve efficient communication? Like, it's kind of a miracle that like as people we produce like a bunch of funky sounds and we know exactly or kind of approximate what those funky sounds mean, right? Super cool. But how does this actually work? So there's a guy named Paul Grice, and he asked this question, and he came up with the idea that people are generally rational speakers, I would hope. And to be a rational speaker, you kind of expect and follow certain conventions in conversations, which we refer to as maxims. So the first is quantity, which is to not undershare and not overshare. Like if I ask you, what did you do yesterday? You're not going to relay like minute by minute playthroughs of what you did from when you woke up to when you went to bed, right? But at the same time, you're not going to undershare and be like, I lived, like, you know, like we already know that you lived, like, tell me a bit more. The second, very straightforward, don't lie, or at least like don't relay information that you know to not be factually correct. The third is relation, be relevant. So same question, like if I asked you what you did yesterday, you're not going to go back to your diary, flip back 1 year and be like, this is what I did 1 year ago. And then finally, manner, be clear, which is something I'm hoping I'm doing in this lecture, but you know, don't say things in such a way that it's going to be super difficult for your listener to parse. Now, it would be great if people followed these conventions all the time, because then we would know exactly what people are trying to convey at every given moment, but this is not always the case. So people can intentionally violate or flout, we're doing flouting first, flout one of these maxims to convey like another layer of meaning, but usually with the intention that the listener will actually understand what they're trying to convey. So a very good example of this is sarcasm, like, I can't come up with one on the fly. I'm totally not blanking right now. That's like, you know, flouting. But you can also break maxims covertly, like outright lying. This is done when like you are violating one of the maxims and you do not want the listener to know that you're violating a maxim. So other things like half-truths, which relates to quantity, when you're undersharing so that people don't come up with a certain conclusion, or with manner, overcomplicating, making your syntax really hard to parse, like in a court proceeding when you're trying to convince the judge by overloading them with information or something like that. So in relation to like the conventions we have in conversation, there's oftentimes multiple ways of saying the thing that we want to convey. But how do we actually choose which one of these options is the best one to pick? So for example, we can choose between different grammatical structures. Like in writing, certain fields may want you to construct everything in the passive voice, like this experiment was conducted, or the bacteria were incubated for X amount of time, versus like in CS, we use active voice constructions like we modeled or we trained, etc. We can also vary intonation and stress patterns, like what Graham brought up with the like 2 bedrooms example. And then we can also choose different vocabulary and constructions. Like I can say certain words that I think are more simple and easy to digest if someone is unfamiliar with the topic. So we have all of these different things to pick from. How do we actually choose them? So this in large part, it comes from 3 different things. First, a speaker's knowledge of common ground, like what are the implicit assumptions they are making about like what they and the speaker like interacts with, or they and the listener like interact with what they have in their environment. Second, what is their communicative goal? Like, is your goal to acquire something? Is it to answer a question? And then finally, related to like the question, what is actually desired by the listener? So for common ground, as an example, I heard this in a meeting the other day, we can launch a bunch of small llamas. Like if I said this in a random Pittsburgh restaurant and like someone was eavesdropping and they have no idea about the current state of NLP, they'll be like, what are you doing? Why are you doing that? So this is a very illustrative example of like them not having like a common knowledge about what you're talking about. Another example is like I've recently been watching The Bear, and if you guys are familiar with that show, it's like about this chef and he's like in really high stakes, high stress situations, so he'll just like yell. And if you really want salt, he'll be like salt, versus like if I'm at dinner and I want someone to pass me salt, I'll be really polite and be like, hey, could you please pass me the salt? So the first one is a very urgent command. Like their goal is to get salt as quickly as possible, versus mine is like, well, I'm kind of chilling with my dinner. I don't need salt immediately, so I can make this very polite request. And then finally, when a listener desires certain information, we can change what we focus on in our answer. So if someone asks like, who trains llamas? I can be like, I train llamas. But if someone asks me like, what do you do with llamas? I can say, I train llamas. And if someone asks, what do I train? I can say, I train llamas. So like surface form, they're all the same, but how I say it changes to like put focus on different parts of my answer, depending on what the listener wants. Okay, we're gonna go to something super computational, and this is rational speech acts. So Grice in his maxims says that like, okay, we kind of follow these conventions, but they're just very like nebulous conventions. They don't really tell us about how to operationalize them in any computational setting. This is a computational theory for how communication may work, and it's a Bayesian model. I'd also like to mention there are other competing models, and not everyone believes this, but it is pretty useful in modeling settings. So RSA views communication as a recursive reasoning process between a speaker and a listener. So it's like, am I thinking what you're thinking I'm thinking, that you're thinking I'm thinking, et cetera, et cetera, et cetera. And this is closely tied to another concept from psychology. Does anyone have a guess to what that concept may be? You know, like, what am I thinking you're thinking? Or like, what are you thinking I'm thinking? Yeah, theory of mind. So yeah, these like pragmatics and concepts like theory of mind do overlap. There's still like lots of debate on like how they actually interact and how they are actually operationalized, like what are the psychological realities of these two things. But yeah, they do overlap. So for simplicity, we can consider a setting of a reference game. So let's say like me and some other person, we have like a basket of colored balls with different properties. I'm thinking of a ball. I want to communicate that I'm thinking of a certain ball. What should I say so that the listener will pick the same ball? This is a reference game. So as I said, this is a recursive model. And the base case for this recursion is a literal listener. So they will select something in their like set of references, only considering what that person has said literally. So like in this example, the literal listener is like the innermost bubble. There's 3 different items they can select from: a smiley face with nothing on it, a smiley face with glasses, and a smiley face with glasses and a hat. They take as input something that the listener said. So the listener said, my friend has glasses. The literal listener will pick the subset of items with glasses. So these are 2 out of the 3 items. So very basic. One level up is the speaker. The speaker at the lowest level will reason about potential interpretations by the listener, with the base case being this literal listener, and choose from a selection of utterances such that the listener is most likely to pick the correct option. So if the speaker was thinking about, okay, how can I maximally identify the smiley face with glasses? They're not going to say, my friend is smiling, because all of them are smiling. So that gives no additional information. But by saying, and then the other option is to say, okay, my friend has a hat, but that's not actually what they want to refer to. So they're going to throw that option out. So from all of the options that they have, they're like, okay, glasses might be the best one. One level up from that is the listener, who is reasoning about potential states of the speaker, who is reasoning about the base listener and thinking, okay, the speaker is attempting to be maximally informative. Out of all the things that they could tell me, why would they pick this one to be maximally informative? And then we can iterate over this process as many times as we want. So we go from base listener to speaker to listener to speaker to listener to speaker ad infinitum. This is actually used, I think, in some of Daniel Fried's work on like vision QA or visual like captioning, I believe. So it is pretty interesting and like is an information theory based perspective on pragmatics. So yeah, these are some interesting things that I did not have time for and lots of things that remain to be studied. So as I mentioned earlier in like the intro slides, there's other fields like neurolinguistics, psycholinguistics, and sociolinguistics, as well as linguistic typology. And I think recently, especially, there's a lot more overlap between questions in some of these more applied fields and current NLP. So here are some example questions that I think would be interesting to explore. First is that humans seem to be really data efficient in terms of their linguistic input. Chomsky even had a hypothesis for this called poverty of the stimulus. He's like, we must have grammar in our brains imbued at birth because there is so little negative examples that we give. Like, how do we actually generalize to rules? Whether or not you believe in that or not, it is quite true in that like literal linguistic input is a lot more sparse for humans than it is for like a language model trained on trillions and trillions of tokens, which is just not acquisitionally reasonable. So how can we imbue this type of data efficiency in models? And like, can we learn something from human processes and human learning to do that? I guess one more specific question from this is how do we learn to generalize from linguistic exemplars? Like if you think about like past tenses, past tense inflection in English, there are some that are irregular, like I went, like I talk versus I talked. But if I say I go, it's not I go, it's I went. How do we figure out when to create a rule given that there are exceptions? Do we create a rule at all? And how many exemplars do we need to create a rule? Another one is very broad. How can we make NLP systems that work better for everyone, including people who speak non-standard dialects and marginalized languages? So in sociolinguistics, this is something that's studied, like the type of variation that you would have in communities and across communities is something that's studied. And when we have like characterizations of why certain speakers would say things in a different way, or like why that change may occur, we can have more informed data collection strategies for NLP systems. And we could also talk about like why certain systems might not work well for others by talking about the actual linguistic variations that occur, as opposed to just saying, oh, they're different. And then finally, one thing that I kind of touched upon was like, nowadays people are making a lot of comparisons between, oh, like language models can do this, humans can do this. Are language models superhuman? But a lot of these things are questions around evaluation, like how do we actually make fair comparisons between human and model language competence? How do we test for this type of linguistic knowledge? And I think this is a very like ripe, active field and would be great if you guys were interested in exploring more. Yeah, I think that is actually all my content for today. So I made it.
Yeah, congratulations. Yeah. So yeah, we actually have a little bit of time for questions about any of this stuff here, if anybody has any. We had a few questions along the way, but there's a lot of yeah, and anybody has things you wanted to ask? Okay, we can also take questions up front if you'd like to just ask privately. I think oh yeah, I've got one there.
These slides are actually a bit different from what's on the website.
Oh yeah, I might have uploaded a earlier
okay.
version. So yeah, I'll upload the ones here, and we'll also upload all the references that she said here. So yeah.
Yeah, so how do we take what we have talked today into account when playing like language models?
What?
Like doing data preparation or the kind of models we need to adapt in order to accommodate those kind of linguistic ideas.
Yeah, I mean I'm going to talk about multilingual NLP where we talk more about it next time. Although I'm not going to talk about it a whole lot. If you have any comments about that, you can say it first.
Yeah, I think like, so the point Graham made about like tokenization, that's a really big one. Like some people have shifted to like byte-based models for like multilingual, but also if you have scripts that are just like not Roman scripts or very like uncommon in your training data. I think it's a very broad question. It really depends on what you want your model to be a model of. Like if you want your model to be a model of human language and cognition, then you would want to make sure your data scale is similar, that your inputs are similar, like people that train on child-directed speech, for example, to study like whether language models can acquire similar linguistic capabilities to children at a certain age. If you want like an NLP system that's more culturally aware or like can handle non-standard dialects and non-standard ways of saying things, then I think that would be more on the data collection side. Like figuring out like what an appropriate balance of data is, like what are those sources, and also just like ethical considerations of where you're sourcing that data from. I don't know if you had any specific like tasks or examples in mind.
Yeah. I can also follow up a little bit. Like when you saw the tour of large language models class that I gave, one thing you might have noticed there is that almost nobody is actually messing around with the architecture anymore of language models. They're all very, very similar. And I think the reason why is people are training on like more and more data. And you can mess around with the architectures, but the differences between architectures grow smaller as you train on more data and larger architectures. And also transformers scale well. All the like GPU-based tooling is around them and stuff like that. So because of that, what do people mess around with? They mess around with data. What do they look at when they mess around with data? They look at evaluations. And how do people make evaluations? Well, a lot of evaluations were designed based on linguistic principles. So kind of, I feel like compared to 20 years ago, the connection, like 20 years ago, for example, there were people working on things where you would actually like parse the input, and based on a parse tree of the input, you would extract semantic structure, and then you would manipulate that to do translation or something like that. But I feel like we're not doing that anymore because we have a lot of end-to-end systems. And so I think a lot of this goes into guiding evaluation. The other thing is, it is still really important for multilingual stuff where we don't have a lot of data in the other languages. And if you speak any language that's not English or Chinese, or actually, if you speak any language that's not English and you use many of the open source like language models, you'll notice they're not even good at syntax in languages. They still mess up syntax in non-English languages. In English, they mostly don't, but sometimes do. And then if you go up to the really big models like GPT-4 and stuff like that, they still mess up syntax in lower resource languages. So, if there are ways we can go in and enforce syntax, and then semantics is even harder because the dependencies are longer, they're more complex and stuff like that. So I think there are still modeling things to be done there too.
My question is kind of related to what you just said about like how architectures are like not really frozen, but they're kind of set at this point. Like, why is scalability the only reason why like more drastic experimentation with architecture isn't happening?
So I don't think they're entirely set. Like Mamba is a good example of that, and like RWKB and other things like this. And I think so. There is still some innovation going on in architectures. I think we don't have a good enough pipeline from experiments on smaller models to larger models. So like what we would really like to be able to do, because I mean, training a state-of-the-art LM costs like $10 to $100 million, and you don't want to run that over and over again to try different architectures. So what we really need is we need some way to do like cheap experimentation with new model architectures that are better in some way, and then like gradually scale it up. And I just went to the, sorry, very quickly. I just went to an open source like generative AI workshop, and there's an architecture called RWKV. It's not from academia, it's from the open source community. And they had this really interesting presentation, which is also on YouTube now, if you want to see it. where they basically say they have the whole community experimenting on 500 million models. Then once they have a kind of like nice looking 500 million model, they then press a button on a larger experiment and run it on 1.3 billion, and then 7 billion, and then they gradually funnel to the ones that they can actually run on like the biggest parameter sizes. So I think not many people can do that effectively right now, and I think that's a big reason why, you know, all of the really competitive models all look exactly like Llama 2, basically. So yeah.
I guess I was asking because at what point is it like something novel we're doing with architecture, or like or like something we're doing with the input versus like when is it just buying performance with parameters?
But yeah, I mean, you can buy some performance with parameters, but you can buy more performance for cheaper with better data, better architectures and stuff like that. So I think like there's actually a bet by Sasha Rush and Jonathan Frankel, Sasha Rush being at Cornell and Hugging Face, and Jonathan Frankel being at Databricks now, where Jonathan Frankel said attention is all you need, transformers are all you need, and Sasha Rush said you don't. And in 3 years, we're going to see which ones are on top of the leaderboard. So I'm really looking forward to what the result of that bet is. Like in 3 years, are transformers going to be at the top or something else? So yeah, we'll see. I don't want to keep everybody for too long, but thank you for the question.